Okay, we're live. So, welcome everyone to the VJug. This is like a 20-something, 20-second-ish presentation on the VJug, and I'm very pleased to introduce. We have Richard Warburton. Hey, Richard, how you doing?
Hey, very well, thanks, Simon.
Awesome. And we have Raoul. Hey, Raoul.
Hey guys, how's it going?
And our usual suspect from Prague, the O-Town.
Hey.
The O-Town General. So Richard and Raoul, both members of the and I guess leaders to some extent of the LJC, which is the London Jug, and it's a pleasure to have them on talking about pragmatic functional refactoring with Java. Oliver, do you own a Jug, or do you do
Yeah,
much in
I
the
mean,
community?
I'm actually the leader of about 16 jugs all over the world.
Yeah,
I do it all behind the scenes.
yeah.
But when I'm not doing that, I have a tendency to spend a lot of time with Rebel Labs. And we've got a very cool article coming out from Roberto Cortez, one of our top authors at Rebel Labs. Hey, Roberto, I'm sure you're watching now. And it's talking about the types of people that contribute to legacy code in your organization. You may remember that he published a popular article about that before, but this time he's doing a follow-up with some kind of recommendations for how to treat, the types of people that you maybe are or come across in your organization. So keep an eye out for that tomorrow, and check out Rebel Labs online.
Cool, thanks, Oliver. And for those of you who have forgotten or don't know, Rebel Labs is the sponsor of the VJug, so feel free to take a look at that at rebellabs.org. One of the other things is we haven't got any sessions lined up yet for Southampton for September even, but beyond this one. But we're going to have one hopefully just before Java 1. We also have a couple more in October, and as soon as I can get the information out for them, I'll put it on Meetup and announce them. Richard, Raoul, you guys are going to be at Java 1 as well, right? What talks have you got going on?
Yeah, definitely. I'm giving a talk called Twins, FP and OOP, about the kind of differences and similarities between functional object-oriented programming and kind of drawing a few parallels between kind of design patterns and functional idioms. And it has a lot of Arnold Schwarzenegger references in, so if you're interested in any of those things, come along. I think I'm also giving a talk on performance and predictability, which is looking at more kind of like how predictable, repeatable behavior in your software makes it easier for hardware and JVMs to optimize it effectively. And I think I'm also doing a kind of user group BOF with Simon as well, and Rabia and Daniel Bryant. So come along to that.
Awesome, thanks for reminding me about that. And Raoul, are you doing any sessions at Java 1 this year? Can you hear me, Raoul?
Sorry guys, I can hear multiple voices at the same time.
You may have the YouTube link open, the virtualjug.com link or YouTube link open, and it's probably coming through that. Okay, while you sort that out, just to let you know then, for those of you who are on the Virtual Jug website, if you can feedback any comments or anything about what's really good, what's crap, we can get that fixed or look into that. Looks like Raoul, you're...
Yeah guys, I've got it fixed. You're right, I had YouTube on. So I'll be also at Java 1. I'll be in a Lambda panel with Stuart, Brian Guts, and some other guys, and we'll be talking about what Lambda expression means for the future of Java. Maybe Java needs some new APIs that makes use of Lambda expressions. We'll discuss whether that makes Java a functional programming language, and maybe we need more functional programming features. Where does Java sit in the functional programming ecosystem? So it'll be a very interesting discussions with a few people with different backgrounds. So I'll provide more of an academic background, and make sure to come because it'll be super interesting.
Awesome, cool. So that's pretty much done. It have been fixed, and it sounds like we're good to go. So without further ado, oh sorry, one last thing. The winner of the VJug book was announced. let me find the winner of that and say well done. The book was Raoul's co-written book, and it was where is it? 48-hour raffle. Win a book. Java 8 Lambdas Pragmatic Functional Programming. Raoul, this is one of your co-written books, right?
That one is actually Richard's
sorry.
one, I believe.
Too many raffles. What was your book? What was your book, Richard?
Yeah.
What was your book, Raoul?
This is my hair, Java 8 in action.
Oh, there we go. And the winner of that, I'll announce that later. I'm having some technical problems here. So let's hand over directly. Do you want to share your screen quickly, Raoul, and we can see the slides?
Can you guys all see it?
Yeah,
Also,
I can see that.
So over to you guys. Thanks very much.
Hey, so yes, as Simon says, I'm Richard,
And I'm Raoul over here.
and hopefully you'll recognise us purely by the voices as we go along. We're talking a little about pragmatic functional programming, and as I imagine, your kind of classic image of your functional programming advocate, your functional programming guy, looks a bit like this person, right, Raoul?
Yes, and there's actually rumors that the longer the beard you have, the more functional you are in real life. And I hang around, universities quite a lot, and I can tell you that there are a few beardy people in the labs, and in general they program Haskell and OCaml and so on. So.
Yep. But we're here to try and broaden the church a little bit, and we're trying to appeal to people who are more, common everyday Java guys like you or me, and try and talk about how you can take some of these functional ideas and some of these idioms and put them to use in refactoring your existing code. So first thing we're going to talk about is first-class functions, which is kind of a classic academic terminology. Whenever we talk about something being first class, what we really mean is the language has some support for it. We talk about currying, which is we're going to show you how you can reuse some of your code and abstract over your code really easily using the the currying technique. We're going to show you how you can reduce possible errors in your data types by both making them immutable and also using the new optional data type in Java 8. And then we're going to come back with some conclusions and draw some threads together. So, first-class functions.
Yeah, and we're going to do things a little bit differently. So instead of explaining you the definition of these concepts and then showing an example of it, we'll start with the examples, and at the end we'll extract what the takeaway is. So let's take this very simple function. So the use case is you've got a list of invoices, and you'd like to find out which invoices are coming from Oracle. So you have a client which is Oracle. So this code works as follows. We create an array list which will hold the result, and we loop through every single invoices we've got. We check whether the current iterated invoices has customer Oracle. If yes, we add it to the result list. And we keep doing that until we've processed the whole invoice list, and we can return the result. So this is all good, but let's say your boss comes to you and says, well, the business is really going quite good at the moment, and we'd like to find out the invoices not only from Oracle, but also from Google or Facebook or Apple.
Sounds like business is going really well if you've got all those people signed up as clients.
One day, yeah. So what can we do? So, a bad software engineering approach would be to duplicate this method and rename it find invoices from Google, and just modify the condition in bold. But this technique doesn't scale because we could have 100 different type of customers, and if we're doing that, we'd have to maintain 100 different methods, which actually at the end of the day are really looking very similar. So we need to take a step back. So we're going to abstract what the customer is. So in this updated method, we're introducing a parameter called customer. So this is really great because now we're able to pass which customer we'd like to find the invoices from. and we've updated the if condition accordingly.
What if we want to have a look at some kind of properties on the invoice that are different from the customer, though, Raoul? How are we going to deal with that?
Well, exactly. So what can we do with that? So, well, something quite, if we take the same approach as before, we could simply duplicate this method. And let's say, hey, we'd like to find out the invoices that end with a suffix. So let's say you're tagging your invoices based on whether they're related to training. So the suffix would be training. Or maybe you're doing some consulting and you like to find those invoices related to consulting. So we duplicate a method and we reuse the same iteration logic, but we just, again, change the if condition. So this is bolded in this code. So that works well for the second property. But as Richard mentioned, what do we do if we have 100 different types of properties? We might want to find invoices that are greater than a certain price, for example. Again, duplicating the methods doesn't really scale. So let's see what we can do. Well, what if we could merge those two methods together, right? That could be an interesting way to reuse the code. What do you think, Richard?
I think interesting is one word you can use. It's probably not the word I'd go for. I think I'd go with hack.
Exactly. We could do a massive hack where we introduce yet a new parameter to the method. So let's say a flag. And based on that flag, we could decide whether we'd like to find based on the customer or we'd like to find based on the suffix. But again, this really doesn't work if we have 100 different types of properties on the invoices. So it's really a messy code reuse. But it's a good idea to reuse code. So let's take a step back again and see what we can do. So really, all those methods only differentiate in the condition that we'd like to operate on the invoices. So what we can do is to try and model this condition. So here we've got an interface predicate that takes something of type T and just has a method test. So what this interface represents is basically a function that will take an invoice and will turn a Boolean. So this is the condition that we want to model. And by the way, this interface predicate is now available out of the box in the Java 8 API. So let's see how we can use that. We refactor our method find invoice. We introduce this new parameter, which is the predicate. And to call this predicate, or to call this function, we need to call the method test and pass it the invoice to it. So this is what the bold condition shows.
So that's the same test method as we defined on the interface in the previous slide.
Exactly. And the benefit now is that we've reused the same iteration logic, but we can now pass multiple different ways to do the filtering. So in this case, for example, we'd like to find out the invoices that are from the customer Facebook and that are related to training. So what we do is we declare a new class called Facebook Training, which implements that predicate. And to implement the predicate, we need to provide an implementation for the test method. And its body shows the condition that we're interested in. Now, if you had a new requirement coming from your boss that says, for example, well, how about all the consulting gigs with Google? Then you do a similar process. You can create a new class that implements a predicate. But you don't need to duplicate the methods anymore. You can just reuse the same method every time. And it's worth pausing a little bit and reflect on what we've done. So we're flexible for any requirement changes now based on the condition that we want to filter with. And that's really great. So now Java 8 introduced a new feature called method references. And we can use it to tackle the verbosity that we've introduced by declaring new classes, right? Every time you have a new requirement that comes in, you've got to declare this new class, implement this predicate, provide the body for the method test, and so on. So that's quite verbose. In Java 8 now, you can basically declare your method. So let's say here, I'm declaring a method called isOracleInvoice that provides the condition to find whether the invoice is from Oracle. We can just take that method and pass it as an argument to find invoices. So we've cut a lot of verbosity. We don't have to declare this inside a new class. What do you think, Richard?
So what you're saying here, Raoul, is that the test method is now being represented by these methods is Oracle interface or is training interface.
Exactly. And we've got the additional benefit that we can reuse the name of the method as well and pass it on. So our code is not only less verbose, but also more readable.
What happens if you only want to use that predicate in one place, though? Do I really need a method every time?
Well, you're raising a good point. So if you would just want to reuse, to create a predicate once, then it's a bit of a pain to have to declare a new method inside a class. So Java 8 provides a new feature called lambda expressions that allows us to create those sort of a throwaway code. So in this example, we're passing a lambda expression as the second parameter to find invoices that says, well, given an invoice, tell me whether it's related to Oracle. The second example says, well, given an invoice, tell me whether it ends with the training tag.
That's pretty cool. So there's no verbosity at all in this case. What happens though if I want to do things like find out about customers who are Oracle and training? Do I need to write a new lambda every time for that kind of thing?
Well, so we'll talk very good point, Richard, again. So we'll talk about a function composition in a moment. So it's a way to compose different pieces of code that you have. And before we talk about that idea, let's reflect a little bit on what we've done. So we've come a long way from a method called find invoices from Oracle to a really flexible method called find invoices that can be parameterized with multiple different requirements. So we can code for any requirement from your bus. But not only that, we've been able to write really readable code. So we're winning from two directions, both from copying from requirements and also from creating readable code. And
sounds great.
Yeah, and this idea of passing the function as an argument to another function, so what we've done is passing lambda expression or passing method references, is what the functional programming guys call first-class functions. So it's the ability to use a function just like a regular value. So when you're passing a number or when you're passing an object to a method, you cannot pass a function. And this is what first-class function mean.
Cool. So you were mentioning about this composing functions point earlier. How does that work out?
Well, so the way I like to think about composing function is a bit like Lego blocks. So unfortunately, guys, I can't see all of you listening to us and watching us, but I'm sure if I was asking you, do you still secretly love playing with Lego, I could see a lot of hand raises, a smile out there. I'm pretty sure, Richard, you still play Lego at home, don't you?
Unfortunately, I don't get time to these days, but if I did have more time, I definitely would.
Who wouldn't, right? So we can, to use the analogy of Lego blocks, you can think about a function as a Lego piece. So individually, they're fairly interesting, but it's when you actually glue them together that you can really build rich designs or real cool things that you want to build. And this is what composing function means. So let's look at an example of that. Here we've got one predicate, which is it a Facebook invoice? And we'd like to create a more complex predicate, which is, well, is it a Facebook invoice, but also is it a training invoice? So instead of creating a new function for that, we can reuse the Facebook invoice function and the training invoice function and compose them together. So this is possible in Java 8 because the predicate interface supports this AND method. And we'll discuss about it in a moment. But it's worth also mentioning that there's another method called OR that we can use. So here, for example, we can compose the function is a Facebook invoice with is it a Google invoice. So that creates us an additional richer function. And this is great because we can reuse them. We don't have to have any code duplication again.
Fantastic. So this is how it works under the hood.
Yeah. So you may be wondering, well, that looks interesting. Well, how does it work? Well, there's a little trick. So some of you may be wondering, hey, wait a minute, Raoul and Richard. How can you have implementation code inside your interface? That's crazy. Well, Java 8 introduced this new feature called a default method. So you can see there's a default keyword in front of the and method. And that lets us have implementation code within the interface. So what this code does, hey, it says, well, given a predicate passed as an argument, we'd like to return a new function. So the function takes, again, something of type T, which is what the predicate accepts. So in our case, it would be an invoice. And we test the invoice given the function. And we also chain it with this other function that is passed as an argument. So the whole return line here creates a new predicate. And that's really the small magic to it. And a similar process can be used to chain the two predicates with an OR operator.
Fantastic. And the lazy operators as well, so it's nice and efficient.
It's very nice and efficient. And this kind of we can build upon this idea of first-class function. So it's not only about passing a function as an argument to another function, but it's also about returning a new function. And to illustrate that even further, we'll look to another example.
So can I just ask a quick question about these funky new default methods in Java 8? Now, here's a question I get asked quite a lot, and I don't know if I've ever got a good answer to it, but I'll ask you guys, and that way I can just reuse the same answer and look smart in my presentations. With these default methods, people are going to be. It's a great thing so that people can change APIs which other people depend on, and add a whole bunch of new functionality into existing APIs, such as what's been done with lambdas and collections. But going forward, how much do you think it will be abused by developers in terms of adding behavior into interfaces when they first release them? And it all depends on how what's the word? How good the developer is in terms of how they design, but 90% of people aren't on these calls for good reason, right? And that's that people aren't that interested in learning Java and aren't that interested in doing the best implementation and design they could. What's the chances of us getting really crap code because people are abusing these interfaces and default methods?
So I think there's kind of two aspects to this one. Firstly, you're guaranteed with 9 million developers that someone somewhere is going to write bad code. Whatever you do, like, that's just a given. That is the real default here. But having said that, I think there's actually some quite good scope for people to come up with some good designs using default methods, not just for evolution. I mean, here's a good example in the core library where someone's added a default method from the get-go on the predicate interface, because what they want you to be able to do is take a lambda expression, so it needs to be an interface with a single abstract method, and be able to have useful functionality composed together by using the default method. So I think it's actually a really good example of the kind of good stuff that people could do. Now, when you first get going with a lot of new language features, it's good to kind of play around and experiment and try all sorts of crazy things. I always think that's a really healthy part of the learning process. But I think one of the things is with things like this that maybe you want to kind of play around and experiment on your own time, and your core production code base. It might not be a great idea to start firing default methods in all over the place on day one until you've got more of a feel and a hang of the kind of good cases that you can be used for. So to me, there's definitely a risk, but there's also a benefit, and it's just about kind of being perhaps a little bit conservative when you first get going, and then once you're more comfortable and you see more examples of good use cases and bad use cases, then you can be a bit more outgoing with the use of default methods.
And I think, like you said, I mean, adding a default method to an interface from the get-go even clouds the distinction between abstract classes and interfaces further, right?
So I think there's still two aspects in which abstract classes and interfaces are different these days. So one of it is that interfaces themselves don't really hold state, whereas abstract classes still have fields which can be inherited and mutated and all that kind of thing. And the other thing is as well with interfaces that you can inherit multiple interfaces, and you can only implement a single abstract class or extend any class. So there's that kind of two-pronged aspect where it's a more nuanced trade-off, I'd say, now in Java 8 than it was in previous versions of Java, where your methods on your interface are really they're an option, but you still can't use state, so there's still that kind of limiting factor, which isn't necessarily a bad thing. And then there's also the more flexibility they give. So they're kind of instead of being two completely separate things, they're kind of touching, but still a bit orthogonal to each other.
Okay, sorry for the questions. I digress, but
that's a pleasure.
No, that was a great question, and let's look at another way to use default methods then, since we're talking about default methods. And the idea is to create function pipelines. So the use case that we'll be using is, let's say you've got an email class, and you've got different methods available to it to create kind of richer emails. For example, in certain cases, you'd like to add a signature to an email, or you might want to add some form of a default header, or you might even want to do some quick check spelling. So what can we do with that? So, Richard, aren't pipelines quite trendy these days?
I always like to think about it as being trendy. When I was talking to people last week and I was telling them pipelines were trendy, they were just laughing at me. The thing is about pipelines, they're an interesting concept, and I'd say, the first interaction I've ever had with them is the idea of pipes in shell programming, where you have that sequence of operations, that old Unix tradition of each thing doing one thing and doing one thing well. So you have cat piped into a grep to find the lines, piped into a cut to pull out the columns, or something like that. And I think you're kind of seeing a lot more of that style of programming come in here, which is also something that has a long-running tradition in the functional programming world. So they're one of those things which is kind of trendy, but also a bit vintage in a way.
Exactly. So the basic idea is, well, out of simpler programs, we can compose them together to create kind of a richer program. And this is what we're trying to do here with this code. So we'd like to create a pipeline that processes an email, but we'd like to first add a header to it. We'd like to do the spelling check and also add a signature. So it turns out, well, the method add header is a function that takes an email and produces another email, but we just add the header to it. So we can then create a processing pipeline by composing all those methods together. And there's a new and-then method, bolded in blue here, as part of the function interface that lets us do just that. So in this example, we've composed 3 functions together to create a rich processing pipeline. But let's say you'd like to create another one. Let's say you're not so interested in the spell checking. Well, in this case, you can just reuse the add header function, compose it with the add signature function, and you get yet another processing pipeline. So this is really what composing functions let you do. So we've talked about first-class functions. So we hope we've shed some light on this funky terminology, and we'll now talk about currying. So I realize it's almost 6 o'clock soon, so you might get hungry. So let's see, Richard, do you want to?
Yeah, so currying. So again, with the currying, we're going to start off with some example code and then work back from that to the functional terminology. So if we take our conversion function, so our conversion function's got 3 arguments. One of them is the amount we're going to convert. The other one's the factor, so that's kind of the ratio that our conversion is going to go up and down by. And one of them is the base, so that's the constant value you're adding on. So very linear, simple conversion, y equals mx plus c stuff. You can use it for converting temperatures, for example. So the base on temperatures from Celsius to Fahrenheit is 32, and the ratio is 1.8.
So what do we want to do if we want to convert with, let's say, currencies or distances?
Yeah, so if we end up, we have a similar kind of situation where we want to use the same conversion code in different places. So for distances, it's a base of 0, very, very simple, with kilometers and miles, because that kind of makes sense, doesn't it? And then the ratio we've got as 0.6137 with a brilliant level of precision there. Somewhat less precise might be, in this case, the currency conversion, where we're looking at, say, a very rough ratio conversion from dollars to pounds of, say, a 0.6 ratio. If you're working in a bank, I don't recommend that you use this code unless you really, really dislike your current job. Yeah, so the key point is you can use the same code by passing the same factor and base values to convert the same thing repeatedly, but you can also use it to convert between different currencies and distances.
But Richard, I noticed in your first example, to convert temperatures, you're actually passing the same arguments twice, right? You're passing 1.8 and 32 twice. So maybe is there a way to extract this into a separate convert temperature function?
Exactly. So we've got two different problems here. Firstly, if we want to write something that operates over different conversion units, we'd have to pass through the same values again and again, so it's not very abstract. And the second part is it's a bit hard to reuse that code in a kind of clean and simple way. I mean, the reuse benefits might not be very obvious because it's a very simple and tiny function here, but as things grow in other more complicated examples, it can be a bit of a win in and of itself. So the approach we're going to outline here is to use a bit of currying. Brilliant.
I'm getting hungry now.
Yeah, I'm getting hungry as well. So the goal with currying is you take a function, and instead of having a big monolithic function which needs to take all of its arguments in one go at the beginning, you break it out into a function that takes one of its arguments and then gives you back another function. And then that can take some other arguments and give you back a function. Then you get it broken up into these little independent, reusable, composable bits.
So I guess this is what this picture shows, right? Instead of having one function where all the dishes are mixed together, you're actually separating each little dish, and then we can combine them later on.
Yes, there is a conceptually sound reason why we're all feeling very hungry at the moment. So if we look at the code example, our convert function is similar to the earlier version, but in a kind of semi-curried form. So instead of taking 3 arguments, it only takes 2. We're going to take in the factor and the base, and then we can apply those arguments, and we'll get a converter. But instead of having a generic conversion function, if we apply those factor and base, we get ones which do things, for example, like each of those different use cases on the previous slide for converting Celsius to Fahrenheit or temperatures or whatever. The value this function returns has got a bit of a nasty name of double unary operator. But what that really means is it's a function that takes one argument, that's a double, and returns one result back, which is also a double. Okay? Makes sense?
It makes sense, and it's worth mentioning that actually this ugly double unary operator is actually also built in the Java 8 API.
Yep, and the same functions package everything else. So we like to think of this step of building the the components by taking some of its arguments and applying it as being a bit like the eating of the curried function. So this is called partial application. That's its scary functional programming name if you want to encounter that. So the example here of partial application, we had one earlier for Celsius to Fahrenheit, but again, you can see that you're using it in different places, for dollars to pounds if you're not a fan of your employer, and also from kilometers to miles, which is pretty safe.
So a good question here at this point from SLB in IRC is he'd like to know why you would use currying instead of overloading.
Why you use currying instead of overloading?
Yes.
So I'm not sure that they're quite the same thing here, if it's talking specifically about overloading.
So the benefit of doing the currying here is that we can actually create new conversion functions on the go, right? So if I want create a new function that needs to convert from Celsius to Fahrenheit, I can use my convert function, which acts as a factory and creates that function. So we can, whereas with overloading, you need to specify, all your different function at declaration time. Whereas here we've got this flexibility of creating those just by passing values to the convert function.
Does that answer your question, Simon?
I hope that answers SLBs. Yeah, that sounds good. Cheers.
Thanks. Okay. So just to summarize what we've been discussing, currying is about splitting up the arguments of functions so you can apply each of them in turn. Partial application is taking that function and putting in some of the arguments and returning a new function. So that lets you build up small reusable functions. And you can write your functions in curried form from the beginning, as we've shown, or you can kind of curry existing functions. It's possible to write a generic currying function in Java as well. But we won't bother covering that today, because that's a bit less useful. Okay.
It's worth mentioning that, we discussed first-class functions at the very beginning of the talk. And currying, the whole point of currying is to return a new function. So this idea of a first-class function is really what characterizes functional programming. So the next topic, which is also an important property of having a functional programming style, is immutability. And let's look at the first example, which is mutable objects. So we're not going to discuss about mutants, X-Men movies, but there's a lot of code, so hopefully you enjoy it. So here we've got a use case which is we'd like to model a train journey. So a train journey has a price, which is a model with the field price, and has an onward journey. So if we want to create a train journey, well, we've got a constructor for it, which initializes its field. We've got two methods, getPrice and getOnward, which will return the value of those fields. But let's say if we want to update the price of a journey, then we've got this method here called setPrice. And what it does is it changes the state of the current objects. And that's what we do every day as Java developers, but it has maybe a little inconvenience. So let's say I'm passing a train journey to Richard, and I'm passing the same one to Simon. Simon has the option to modify the price of its train journey. But because Richard and Simon are actually sharing the same object, then Richard will also see his train journey modified, right? So there is a different way to do things, and this sort of mutation is undesirable. For example, if you have several threads and you're sharing an object between them, you might not want to have some sort of data interference. So a different approach to do things is what we call immutable objects. So it's the general idea that once you've created an object, you should never modify its state. And there's a couple of protections to go about doing this. So the first one is we want to declare all the fields of the class as final, and that ensures that we can't reassign to them. So for example here, instead of having setters, we have a method called withPrice, which given a price will create a new train journey with the price as a parameter and the current onward journey.
I think it's worth noting as well that the final keyword on the fields firstly ensures that you don't accidentally introduce a bug by reassigning them. And it also documents the idea that they're not going to be mutated in your code moving forward. But it also has a third purpose, which is if you're taking this object and handing it out to multiple threads, that object's properly safe for publication, which means that the compiler isn't able to, hoist or move that code which assigns to the fields beyond the end of the constructor. So once your constructor is called, it's guaranteed that those final fields are initialized.
Yes, and there is an additional protection that we need to take is that, well, if we have a field that's declared final, it doesn't actually make that field immutable. For example, if we had a field that is a final array, well, even though we can't reassign to that field, we can still modify the elements within that array. So we've got to be a little bit careful when we make use of a final. So you may now be wondering, well, how can I benefit from using immutability in my code? What's actually the use for it? So we'll look at a scenario to illustrate the difference between taking a mutable approach and an immutable approach. And the scenario is, given two train journeys, we like to link them together to create a longer journey. So the first approach is what we call destructive, or what we call a mutable approach. So let's say we've got two train journeys here, a start train journey on the left side and a continuation train journey on the right side. This X in the box just means it's the end of the journey, so it would be represented as null. Well, by linking them using a mutable approach, then we'll be changing the state of the start journey and linking that up to the continuation journey. So in code, it would look like something like this. So giving two train journey paths as a parameter to link, well, first we'll check if the start journey is null. If it is, then, well, we can just pass the continuation journey because we don't have a start journey. But if it's not, then we want to find out what the end journey is. So what this code does is basically you loop through all the onward journey until we find the last one that is not null. And we set that to the continuation journey. So it's important to notice that the set onward method here is mutable. It will change the state of the train journey.
So it's a bit like a linked list in terms of the way it's implemented.
Yeah, it's like an implementation of a linked list. So you may be wondering, well, that sounds reasonable to me. So what is actually the problem with this code? So, you know, if we try to merge two journeys and we try to do it again, it's fair to assume that we like the same result to be passed back. So here we've got a simple visit method that takes a train journey, and we'll just recursively go through all the journey and print the price. So if we do that, then we'll have a bad surprise. Actually, we'll get a Stack Overflow error, and this is the reason for it. So before we call the link the first time, we'll get those two train journeys that are separate, which is great. After we call it the first time, then the start journey is now linked, is mutated to be connected to the continuation journey. The second time we call it, well, our algorithm is, you know, processing this whole list of journeys until it finds the end journey, which is at the end of continuation now, and then links it back to the continuation journey. So we've created a cycle in our linked list, and that's why we will get this sort of Stack Overflow error.
Wow, that's nasty. So how does the immutable approach help us work around this problem?
Well, so the mutable approach, which is the immutable approach, which we also call the functional style of approach, is instead of modifying the start train journey, we'll create a copy for it, and then we'll link that to the continuation journey. And this is what this diagram shows. And in code, it can be really concisely written. So we've got, again, a link method that takes a start journey and a continuation journey. And what it does is recursively just copies the start journey nodes and links it with the continuation journey. And that means that in the future, you know, if a user wants to reuse the start journey, well, it's completely independent now from its copy. And this is great because it's a good way to limit the scope of potential bugs that you can write in your code. And this sort of approach and these techniques is a good practice in many different fields.
Yeah, so I think the domain-driven design guys have really started using immutable objects and immutable value types very heavily for things like value classes and also for messages that go between systems. The core Java libraries have had quite a few improvements around using immutable classes. So the date and time library in Java 8's got lots of immutable objects. The optional value in Java 8, which we're going to look at in a bit, is also immutable.
But there's also a few classes that historically have also been immutable. So, for example, string is an immutable class. There's also integer. So it's not really something new. It's actually been around for some time as well.
As it's been around for a while, you also get quite good support from tooling to help you write immutable value types. So, for example, the final keyword, which we showed in that example, is very helpful for banning reassignment. It's not the complete end of the word. It's not the complete be-all and end-all solution to the problem, because you can still have a final variable with a mutable value in. There's a new JSR, well, not new JSR, but a JSR in Java 8, which allows you to put annotations all over the place, which makes it much easier to write detectors for this kind of thing. There's also the GitHub project, Mutability Detector by Graham Allen, which is good for testing your code to make sure it genuinely is immutable and genuinely meets the contract. Now there's also good old find bugs. You can put an annotation on the code saying it's immutable, and find bugs will check that code and see if it genuinely is.
So to wrap this up, basically, essentially, immutable objects lets you reduce the scope for bugs. And we're now going to talk about a fourth and last topic, which are optional data types.
Yeah. So everyone's favorite bug, the null pointer exception. Don't we just love it? It's the kind of thing that appears in your code very regularly if you sit there on a Friday afternoon, you've done your final bug fix or feature addition for the day, you push your code, goes through your continuous release system, goes out in production, everything's great, hop down the pub for a pint, and the moment you get there, you're going to get an email from your notification system saying, there's a bug in production, it's guaranteed to be an NPE. So, obviously, we kind of want to solve that problem, and that's what we're going to be talking about in this section. So, if you've got some code which looks like this, it can be even harder to figure out where the NPE is, because you've got a person that you're going to dereference to get the car. So if that person's null, you could get an NPE there. If the car that gets returned is null, you can get an NPE there. If the insurance that gets returned is null, you can get an NPE there. Poor old Wally here spent so long looking for NPEs in his code that he lost confidence in his abilities as a programmer and started hiding in large groups of people, never to be seen again, or very, very rarely to be seen again. So, what do? The first thing we can do is be very, very defensive in our checking. We can take our person in and we can check our person isn't null, we can check our car isn't null, we can check our insurance isn't null. But this is quite boilerplatey. It's also kind of obscuring the intent of what's actually going on.
Yeah, so from one line of code, we've come to at least 10 lines of code.
Yeah, it's a big blow up. It's also not very clear what's actually going on here. I mean, is the person really null? Are they not null? Are you writing this defensive checking for a good reason? Are you writing it for a bad reason? You don't know whether things are nullable or whether they're not nullable. There's a solution introduced in Java 8 called the optional type. So an optional type is like a collection or a container which can only contain one value, or 0 or 1 values. So what this means is that you're explicitly modeling in your domain whether you have a value or whether that value is optional, because it's either is present or it isn't. And it also makes it easier to maintain the code because you can easily see and understand and just instantly look at that code and go, that's optional. It also encourages you to reduce the number of bugs when you're writing the code, because in order to use an optional, you need to actively unwrap it in some sense. So there's a few operations you can perform on an optional, or you can do gets that also pass in default values and things like that, generally leading to fewer errors. So let's have a look at a couple of the methods that we've got on optionals.
So Richard, on the libraries before Java's release that have kind of suggested this idea of having an optional class as well.
Yeah, I mean, optional is not a new idea. It's been around a bunch of functional languages for a while, and the Guava library, which I know plenty of people use these days, has an optional class in it itself. but it's good to see it move to the core library. So if we update our model in our person, our car, because a person may or may not have a car, is now optional. Very clear, well documented. In the car, a car may or may not have an insurance policy. Now, I know what you're thinking. You're thinking it's, if you're in the UK at least, you're thinking, well, my car has to have an insurance policy, but maybe that's not the case in every country, or maybe you've got a car which is only being used for driving around on a private residence, or maybe it's a car that's not being used at all, so people aren't paying for the insurance on it. And our insurance policy definitely has to have a name, so that's guaranteed. So we want to be able to perform some operations on our optional values in order to get values out and transform them. The first operation we can perform is the map operation. So what a map does is it lets you apply a function to the value inside the optional. So if you've got an insurance policy, you can get its name, and then you'll get an optional back with its name in. If there was no insurance policy to begin with, you'll get an empty value back on the other side. So at no point in time are you risking an NPE with your code. Another thing that's interesting to look at is the flat map. So if you have something like a car that's got a get insurance method on it, where it's a method that returns an optional itself, and you want to try and apply map to it directly, you'll get optional of insurance. This is the kind of code that drove Wally insane in the first place. So what we want to do is we want to use a flat map, which takes a function in that if there's a value in the optional, it passes it to that function, and it returns the optional that function returns. If there's no value, it'll return you another empty value, another empty option. So it's very useful. So we return back to our example code for MPEs. This is an alternative to the defensive checking approach. So we take optional.of_nullable person. So that will create an option that is got the person value in if there is a person, or it'll be empty if the person was null. It's quite useful for integrating into existing code bases and bringing optional into play incrementally. We're going to flat map on that person to get their car out, and we're going to flat map again on the car to get the insurance policy out. Now we've got the insurance policy, we know it's got a name, so we can use map to get the name out. Finally, if there's no insurance policy associated with this person, we're going to return the string no insurance and just display that in UI for our end user. So we can use this or else method, which if there is a optional value, it'll return that value. If there's no value, if it's empty, it'll return the value you provided, the no insurance value. So we get our string back out at the end, and there's no NPEs anywhere through.
So one thing worth mentioning is that by using optional, you're forced to kind of deal with the case where there may or may not be a value just by the fact that you're using the optional, you have to work with its methods. You might say, well, using a defensive checking, we get the same benefits, but you could always forget to check whether some property is returns null or not, whereas with optional, you just can't. So consistent use of optional replaces the use of null and lets you reduce bugs, and as Richard is saying, makes Wally happy.
Yeah.
And SLB in the chat in the IRC has just come up with a great line, which is for those of you who are nostalgic, you can also write optional dot or else throw a new null pointer exception, just for those of you who are nostalgic and missed them.
Yeah.
If you're feeling nostalgic on a Friday night, you've got always that option. Great, so we're reaching the end of the talk, so just going to summarize what we've seen. So we introduced some functional programming techniques, and we hope that you've seen that functional programming techniques lets you write more flexible code. So using first-class function, you can code for requirement changes by passing a function which represents requirement as an argument to another function. You've seen what currying is, which lets you split the parameters of function to reuse code logic and also gain additional abstraction. You've seen that mutability let's reduce the scope for bugs. And finally, we've just shown you optional data types that lets you reduce the null checking boilerplate and prevent null pointer exceptions.
Cool. So at the beginning, we were talking about this big divide between academics and kind of regular day-to-day developers. Hopefully, the kind of techniques you were talking about today give you some of the kind of ideas and concepts that let you take the best of both worlds. And just to clarify on the good old plug slide, because every talk needs a plug slide, Raoul and I, with James Goff, are running training around Java 8. If you go to java8training.com, you'll see it's there. We're currently running in the UK, France, Holland, and also upcoming in Sweden as well, beginning 2015.
So it's a 2-day intensive course, and in 2 days you'll get to see all the new Java 8 features and how you can benefit from them to write more flexible and robust code.
Yeah. Now, that training course actually came out of 2 books that we wrote. So I wrote Java 8 Lambdas with O'Reilly Media.
And I wrote the one on the left with the funky samurai guy called Java 8 in Action.
Fantastic. Cool. So I guess we took a couple of questions during the talk, but if anyone else has any questions they want to ask or anything else, then you're more than welcome to pass them through. Simon?
Okay, so I've put a request out on IRC for some questions. Just to go over the who won the book in my real noob approach of trying to go through Meetup. I struggled at the start. The person who won Raoul's book is Kevin Klein, which does sound like a knockoff perfume, but it is Kevin Klein who won the book. So congratulations! Shout out to Kevin. You might be online at the moment.
Congrats, Kevin, and please let me know any feedback you may have.
Cool. And okay, so we've got some questions in. So Zoran, a comment: for me as a total functional noob, this session is great to get up to speed. Milan, here's a question. Do you think the groovy Elvis operator will make it to the next Java release? This optional still feels a bit too verbose. So for those of you who don't know, the groovy Elvis operator is the kind of like the tertiary operator, right, where it's question mark colon, and basically you check an expression for true or false. If it's true, you return that expression. If not, you return something else. So it kind of does mask that null pointer exception.
Well, so it's worth mentioning that actually the Elvis operator was proposed as part of what we call the project coin. So it was actually proposed for Java 7, and there was a lot of discussion around it, but it didn't make it into the language. But Richard, do you think that's likely to change?
I'm not hugely objectionable to the concept of adding the Elvis operator, but I'd really rather people just try to remove as much usage of null from their code as possible, rather than kind of work around its existence with things like the Elvis operator. I appreciate if you've got a big legacy code base, there's a bit of pain involved, but you know, it really is going to lead to better benefits in the long term than just avoiding NPEs.
Yeah, so it's unlikely to make it. At least for Java 9, it's pretty clear that it won't, and for Java 10, maybe there'll be another project cone sort of things, but it's unlikely, I guess.
So in terms of things like the Kotlin, I'm not sure if Scala does it. I think it probably does. The Kotlin's where you have null safety, where you have question mark dot, where it only dereferences if the value is non-null. You dislike them. You prefer it if people knew that their values and variables are null or not, right?
I would prefer it if people avoided using null as much as possible, and if they have a value that's inherently optional, you can explicitly model it with an optional data type. Yeah.
Okay, cool. Okay, so let's have a look at more questions. Please add some questions now. So Maldivia says, not completely functional related, but with JDK 8, map got a new default method, get or default. Is there a reason there isn't a version that takes a supplier So for more advanced value objects, you don't have the construction cost unless it's actually needed.
So so there's two aspects of this. Firstly, with a supplier, it's quite likely that you might want to capture a value from a surrounding scope, in which case you would end up with some cost. The other thing is what you're really wanting to do if you're creating a supplier is, or well, what's probably more sensible to do if you want to create a supplier is actually put that value back in the map after you're done, right? It's not just that there's a default value you want to use, it's that you want to be able to associate that value with the key afterwards. And there is actually a method called put if absent, which has also been added to map, which lets you provide the key and the supplier. Actually, I think it's a function from the key onto the value you want to create. And that means that you can create those new values incrementally as you're going along, but then they'll be stored in the map afterwards. So that's also something to think about.
Cool. SLB says, using optional seems to be very invasive. Any suggestion on lifting existing functions or adapting classes?
I think one of the things with optional that can be quite bad is if you first start using it, there's a big tendency to just create an optional somewhere and then call get or else, or get or else throw, that kind of thing. So you only use it at one point and then you come back out again and you end up making them very small. Well, something which I find quite useful for not for kind of using optional to the fullest is making best use of those map and flat map operations. So you end up with kind of tying together a sequence of operations with optional at the outer end, if you know what I mean. Does that make? Do you have anything to add, Raoul?
Yeah, I mean, I agree with what you're saying, but it's also worth mentioning that actually the Java API, specifically Streams API, also makes use of optional. So it's likely to be potentially a trend in the future.
Yeah.
One also interesting point actually from Milros Jez in IRC, nested null checks are pretty invasive too, which is pretty true. One question from Aishan P, I think it is, the difference between map and flat map. I didn't actually hear you go through it. Maybe you did, but I was just doing something else. But the basic difference between map and flat map.
So I'll show the diagram again. I think that will be helpful.
Yeah. So the idea with optional, so one way to think about the optional is a collection with a single value in. And what a map is doing is it's transforming that value inside the option. So if there's a value, it'll transform the option and it'll then box that value back up in a new optional and return it back to you. And if it's empty, it'll be empty. But if we look at the flat map, it will take the function, and the function itself will return a new optional. So the example we were using here was the getInsurance method on car was returning an optional value itself, and we didn't want to end up in a situation where we had optional of insurance, so we just flat mapped that getInsurance, which gave us the optional back.
Cool.
You want to add anything on that front?
No, yeah, I think so. The main confusion that comes between map and flat map is that you really need to remember the getInsurance method here returns an optional of an insurance. So yeah. when we call map, this is what we get is kind of a double boxed optional, and this is not what we want to achieve. We actually just want to have a box with an insurance into it. And just to get that behavior, simply remember to call flat map, which kind of flattens those two boxes together.
Cool.
Okay, so just looking through, I can't see. There's only one final question, which is really probably for Raoul, from a guy called some sketchy guy called Java Jim London, who's from Mumbai, I believe, right now. Raoul, would you mind unsharing your screen? The question is: has Raoul grown a beard as big as Richard's yet? Now he has finished his Java 8 book. So a really important one to finish off with.
So. Unlike Richard, I do shave every couple of days or so. So my beard is not growing very much. But maybe if there's a general trend, if you do it, then I'll definitely grow a beard as big as Richard.
Well, I guess as Richard said, the longer your beard, the more functional programming you do, right? You shouldn't be giving this session unless you have a beard as long as Richard's.
We're trying to get away from that stereotype.
Okay, guys, we've just gone past the hour, so I must say that was a really great session. I think from the response from people attending sessions, it looks like these kind of sessions are the most well attended. So I'm going to try and focus more on these kind of deep technical dives around certain pieces of functionality. If people disagree with that, I guess answer with your feet in RSVPs, and we'll move things around. Please give us much feedback on this session in IRC, and if you have any further questions that we didn't get round to, ask them in Meetup, and I'm sure Richard and Raoul as Meetup hosts, I think you should get notification of that, so please keep an eye out for that. Yeah, guys, awesome session, really deep technical session. Thank you very much for...
Thanks for having us as well.
Yes, yep, definitely.
Cool, I hope you guys enjoyed it. Oliver, any final thoughts? How did you find that deep technical session, Oliver?
I learned a lot, actually, as I almost always do. I liked how Raoul and Richard kind of engaged each other, which led us to be a little more engaged. And even though I was laughing at the little witticisms, but I was on mute, I'm sure a lot of our viewers were doing the same. So I thought it was really a breath of fresh air in the typically stern, hardcore VJug sessions that we're all aware of.
Absolutely.
Thanks for the kind words.
Excellent. No, thank you very much for attending. Awesome session. Thank you again, everyone else, for attending on IRC. Great discussions. I'll add them into the session. So Richard and Raoul, I definitely suggest you check that out. I'll add that to the VJug website. Guys, we're very close to 2,000 members in our first year. So please share this session as soon as I send it round. Share the VJug, get all your friends, families, pets to sign up and watch our awesome content. So for now, thanks. See those of you who are going to Java Zone next week in Norway. I'll see you there. For those of you going to Java 1, I'll see you there. Hopefully we'll have a session before that, as I mentioned, on the JCP and some JSR funkiness. Thanks for attending. See you soon, guys.
Bye.
Bye-bye.